Hello everyone. So this is Sam Mohammed Hussain. So I'm just going to walk through my final project which I've done for recommended system. So I took the Movie Lens 1 million movie rating dataset, and then I'm trying to perform some analysis on collaborative filtering and with item-based collaborative filtering and user-based collaborative filtering, do some performance analysis, and then come up with the best model. Also, I'm going to do the same with the Spark implementation with the ALS algorithm, and to see which one is performing better, and what is the prediction given by the Spark, and using the recommended lab package. So just to start with, I took the 1 million dataset from the GroupLens website. I downloaded it, and then I converted into the CSV file, but just for the ease of process. These are some data exploration which I did. Basically getting some summary of the movie rating and what is the unique uses we have movie, something like that. And then did some small graphing on the movies, number of ratings by the movie ID, and the number of ratings by the user ID, just to get some insight on how the data got distributed based on movie and users. And look into the sample data set. This is how it looks like. It has a user ID, movie ID rating, and then the sample movie data set would have the title and genre associated with that. Next, I did some data wrangling, so just to get the what is the genre of movie. We just segregated based on a different genre, based on movie title. This will give this might help in the later part of the analysis if we are doing on the movie based, genre based recommendation. Then next, coming to the model exploration. So since we are focusing on user based and item based collaborative filtering, so first step is we need to convert the data set into the sparse matrix conversion, so which I'm doing here, and then performing what are the available packages recommended from the recommended lab. So what are the packages we have, models we have, and then I'm doing some similarity between the item and users using the correlation matrix over here. When I see the correlation matrix, so the values are relatively closer to each other. So that's why we have these similarity correlation graphs looking so similar. Then we did some data distribution, so how the data has been distributed based on the vector ratings. So this is how it looks like based on the ratings. So you can see that the 4-star rating was given to the most of the movies, and this is a visualization of the heat map. Just for the example, so I just took the 20 rows and 25 columns just to get a better view of the heat map. Now coming back to the actual model. So the first thing is I'm going to address on the item based collaborative filtering. So so before doing that, we need to set up the dataset, training dataset and testing dataset. So I just classify in 2 ways. Training will be point that the distribution of partition between the training and testing was 80-20%, and then building the IBCF model over here, and let's see how the distribution count and what are the movies recommended by the IBCF model. So these are the movies for the first movie user 1. These are the movies as well, like a top 10 movies basically. And so this is about user-based collaborative filtering, and next moving to the item-based, and moving to the user-based collaborative filtering. So it's the same technique, same way of coding. So I applied, and I found that let's see how this is the distribution of item which got, and these are the recommendation by UBCF model. And then next, evaluation of the model. So since we developed the model and got some of the results, right, so titles, so then the next step is the evaluation. So evaluating, so basically we have different technique applied. So first thing is the bootstrapping. It's a splitting of data and perform the method of bootstrapping to get the evaluation. The next thing is k-fold. So I did both of them, and I picked the k-fold results looks promising. So so I took the approach on a k-fold to perform the model validation. Yeah, so and then I did some accuracy measures on top of that. So these are the accuracy measures: RMSE, MSE, and MAE. The same will be, we can compare with the later with the Spark implementation. What is the measures we got from the Spark implementation. So the next thing is I did some analysis on the probability threshold, finding the true positive, false negative, true negative, something like that. So to get the confusion matrix on of that. So these are the results: the ROC curve and the precision recall curve. So if you see here, right, the small percentage of rated movie, the precision decreases, but the higher percentage of rated movie is recommended for when the recall is higher. Yeah. And then the next step is comparing the different models, item based with cosine and Pearson correlation, the same with the user based cosine and Pearson correlation. So these are the results. So looking into the ideal model based on the comparison, so we'll see the ROC curve and the precision recall curve. And if you look at the green over here, the UBCF with the cosine is performing better. So in this case, movie lens, based on this analysis, so we can say that user-based collaborative filtering with the cosine is a good model. Yeah. So next, the same thing, the same data set I'm going to implement on the Spark. So I'm just setting the configuration over here and copying the data to the Spark, and then splitting the data set the same way which I did for the recommended lab, 80-20 ratio, and then using the ALS model to predict the ratings. Yeah, so the RMS, so it got predicted, so I have the results over here. If you see here, the actual rating from the dataset and the Spark prediction over here, somehow for most of the cases is somehow related. So if you see here, the actual rating is 3, the Spark was getting 2.03, but over here it's 2.8 by Spark, and here I could see maybe we are playing with a small set of data sets, so we don't get the Spark prediction rightly, and I didn't explore so much of algorithm. So because of the system limitations. So these are the results, Spark prediction using the same data set, and these are the root means accuracy values. So when we compare the accuracy value of Spark and with the recommended lab, what we are having is here the value is more in the recommended lab, whereas in the Spark it's it's almost 30% lower compared to the recommended lab. It's because of the distribution system, and Spark is performing way better than the conventional recommended lab package. Yeah, that's all for the project. Thank you so much.